First, I want to ask you guys, how many of you have some experience with machine learning, just in general? Great. And for how many of you this is the first NLP experience? Great. All right. Let's go right at it. So, what's the motivation about naive Bayes? First of all, is a machine learning algorithm. It's a pretty general purpose algorithm, but it's mainly used in NLP because it works so well in that realm. So let's talk a little bit about the motivation, and then we'll get to the nitty-gritty details. So basically, it's a really simple and easy to implement algorithm. If you want something that's super easy, that's like a low-hanging fruit that you can implement in production and it would scale amazingly, you should go there. It's used in document classification, which we're going to use today. Spam filters, it's actually used in production systems in spam filters. And it relies on the bag of word representation that Uri mentioned, so I'm not going to go into too much detail about that. So just let's set up the stage. So the training goes, we have a document, we have a bunch of documents, and we have a set of classes that we want to map those documents to. Let's say sports and not sports. And basically, at the end, we want to have a prediction that says, given some document, what's the probability of some class? What's the probability of the class being sport given some document? So the assumptions that go into the model are the bag of word assumption. The bag of word assumption, basically what it means that the order of the words in the sentence does not matter. So I'm a data scientist, and scientist data would be the same, would have the same prediction. And conditional independence, which basically means that this is a pretty strong assumption that's usually violated in normal scenarios, but we still perform quite well with it. Basically what it means is that the word degree would be equally likely to be in a sentence if the word university is in it or not. So you can see that in real world scenarios, this assumption is violated quite often. I'm not going to bore you guys too much with this, but basically what I'm trying to kind of go through the process. So what we're trying to do is we're trying to find the probability of some class given a document. Right? So we're going to run for each class, and we're going to compute this. Statement. So basically what we do is we use Bayes' rule to transform the conditional probability, the probability of a class given a document, to be the likelihood of the document times the prior probability of the class, and we divide it by a normalizing denominator, which basically can be dropped because this equal sign becomes a proportional to, and then we just multiply the likelihood times the prior probability. And basically what that means is, I'm just trying to give you guys a bit of intuition. It means that it's just a counting step. So how many, now we break the documents into the word that's actually in the document, and we just say how many times does the word appear given a class, and what's the prior probability of a class. We're going to dive into an example, and it's going to be super clear. So can everyone see? Is it okay? All right. So we have some toy data set, and we have sports and non-sports, and we have some text, and we're trying to classify whether or not a new sentence that we haven't seen yet is sports or not sports. So basically what we do, the first step, as you can see, we need the prior probability of the class. The classes here are sports or non-sports. So we have to say, what's the prior probability? Given I don't have any information, I don't have any document to classify, I just have to guess whether or not it's sports or not. I would, 3 out of 5 times I would guess it's sports, and 2 out of 5 I would guess it's not, because that's what I have in the data set. That's the prior probability. So now we're trying to let's get a new sentence, a very close game. And let's see if we can try to classify whether or not it's sports or not sports. Intuitively, we know it needs to be sports, so we can check ourselves. So what we do is basically we say, we break it into words, and we say, what's the conditional probability of which is the first word, given sports. So we just count the times the word appears with the sport label. So it's 1 and 2, right? So it's 2 divided by 11. What's 11? It's 3 here, and 5 here, which is the total number of words that appear in sports in general. So we have the likelihood of a given sports. We can do that for very, and now when we get to close, a very close game, we have a problem. Because close does not appear in the context of sports in this data set at all, right? So what do? We smooth. What does that mean? Basically, we add 2 synthetic documents to our data set. We add this and this one. This has a grandiose name, but it's super simple. It's called Laplace smoothing, or add one smoothing. Basically what it means is add the entire vocabulary to your data set with the label sports, and then add the entire thing to the data set with the word not sports. So basically what we have on the left side is exactly the same thing with the smoothing applied. So now with the additional 2 data points, we have it's 2 divided by 2 plus 1, which is the added one that we just added, divided by 11 plus 14, which is the set of total number of vocabulary words. Right? Is that clear? Right. So we go about and we compute that for every word. And then all that's left is just to multiply the probabilities. So we take a given sports, very given sports, close given sports, etc., which are now not, which cannot be 0 because we've smoothed the whole thing. And then we multiply by the prior, the probability of the thing being sports, and we get results. So as we can see, our sentence was correctly classified as sports because when we multiply it, the end result is bigger for sports. Now, just a tiny, just to take a sneak peek inside the algorithm, basically when we multiply probabilities, what we do is the number diminishes with every multiplication, because probabilities by definition are bounded between 0 and 1, right? So when the probability of a word given the class is higher, it diminishes the number just a tiny bit less. So basically, if we take the word game and we say how indicative is the word game for the class sports, we can compute the likelihood, the marginal likelihood of the word game given sports, and the marginal likelihood of the word game given not sports, and just divide the two. And we say that if the word sports is in the game, it's 2.76 more likely for it to be sports than not sports. That way we can take apart all the words in the vocabulary and say what's their marginal contribution to each class. Right? What? Just the last part? Yeah. So basically what we did here is we computed the likelihood for every word with every class that we have, right? And we can, this is a generative model. So we have a model for not sports, regardless of the model of sports. So we have like game, this is its contribution to the general probability of the class being sports. And this is its contribution, marginal contribution to the general probability of not being sports. The fact that this number is bigger than this number means that the word game is more associated with the label sports. How much more associated? You guessed it.
And what did you
sorry. Uri doesn't allow questions, right? Yeah, he's gonna chop my head off. I went over like 15 minutes. Right. Thank you guys very much.